Okay, we're going to solve quadratic equations using the square root property. So this applies to quadratic equations that have the form x squared equals some number. So let's just call it b. And if we have it in that form, what we can do to solve it is to take the square root of both sides. And so we end up with x equaling plus or minus square root b. All right, I left the plus or minus off up here. So whenever we introduce a square root to an equation, we have to take into account that it could be the negative case or the positive case, right? Because if we square a negative square root b, we're going to end up with a positive b. And if we square a positive square root b, we're going to end up with a positive b. So it could be either positive or negative. Okay, so let's do an actual example. Okay, we've got x squared minus 25 equals 0. So this isn't in the form that we want, x squared equaling something, but if we add 25 to both sides, right, we end up with x squared equals 25. All right, and now we can apply that square root property by taking the square root of both sides. So we put a plus or minus out in front of the square root of 25. The square root of x squared is just x, and the square root of 25 is 5. So we get two solutions. So what this means, x equals plus or minus 5, it means x equals 5 and x equals negative 5. All right, so it just means there's two solutions. There's two numbers, two values, that if we plug it back into that equation, right, if we plug in 5, square it, minus 25, that equals 0. And if we plug in negative 5, square it, subtract 25, that equals 0. Okay, look at this example. Now, again, the key that we're going to be able to use the square root property is that there is no x term. So no term in the quadratic equation that has just an x, right? We've got an x squared, and then we have got constant terms, but we don't have a x term. We don't have like 3x or negative 5x. So that's the key to being able to use the square root principle. Now, we do need to get it so that it's just x squared equal to some value. So we want to isolate the x squared. Okay, so it's like we're solving for x squared. So we're going to add 10 to both sides to start off with. All right, so we get 3x squared equals 60. And now to get x squared by itself, we divide by 3 on both sides, and we get x squared equals 60 divided by 3, which is 20. All right, now we take the square root. It's going to undo that squaring. Do that to both sides. So we've got x equals plus or minus square root of 20. So 20 has a factor that's a perfect square, right? 4. 20 can be written as 4 times 5. So we can write this as x equals plus or minus square root 4 times square root 5. And then, of course, that square root 4 will simplify to 2. So our solutions are x equals 2 square root 5 and x equals negative 2 square root 5. Okay, this next one, we don't have just x squared, but we do have something squared. And that's what we want to isolate. We want to isolate the x minus 3 squared. And then we can apply that square root property. All right, so we're going to add 49 to both sides. So we get x minus 3 squared equals 49. And to undo the squaring on the left side, right, we're going to take the square root, because that undoes that squaring, and we're going to do that on the right side too. So plus or minus square root 49. So we end up with x minus 3 equals plus or minus 7, and add 3 to both sides to get the x by itself, and we end up with x equals 3 plus or minus 7. So this is going to give us two solutions. The plus case, we get 3 plus 7, or 10, and the minus case, 3 minus 7, a negative 4.